Hello everyone, welcome back. This is the 7th video in the series, and in this video I'm going to show you how to add the meteors onto the screen and make them move around. Let's get right into it. Before we write the code for the meteors, let's talk just a bit about what they'll look like. So we want to be careful that the meteors never just disappear or appear randomly. We want it to seem really natural. So the way I'm going to set it up is once they leave the outer force field boundary is when they're going to disappear, and then when I add them to the world, it's going to be off camera so that it won't just put one where the spaceship is and then you'll crash into it immediately. That'd be bad. We're not going to do that. So with those things in mind, let's get into the programming. The first thing I'm going to do is add an object that holds the URL for the meteor. I'm just going to put it right into the object map, and this is going to be called Meteor. So there'll be a new web image holding that URL. And then we're going to access that later. And it's good also to have it at the beginning, so it just initially gets loaded in so we know that it can load that web image. And next, let's write the code that adds the meteors to the screen. I'm going to set up the meteors a little bit differently than the stars in the spaceship. With those, I add them all at the beginning, but for the meteors, we're going to be getting rid of them. Either they'll get blown up by a laser beam or they'll exit the world boundary. So they're going to be always changing. So we're going to need to actively add meteors to the game. The first thing I'm going to do is add another array. So this is going to just hold all of the meteors. So they'll just be called meteors and initialize that to an empty array. The next thing I'm going to do is grab that, and inside of our init game function right here, I'm going to initialize it to an empty array so that it'll clear out all the old meteors from the previous game. The next thing I'm going to do is add a couple of constants here. So there's going to be variable max number of meteors, and I found 200 looks pretty good for that one. And then the next one is going to be meteor speed, and that'll be equal to 5. So right now they'll just go at a constant speed. So now we can write the method, the move meteors method. The move meteor method will also replenish the meteors to the canvas, as well as move them around the screen. So it'll all be taken care of in that. So I'm going to go down to where I have the other move functions. Here I'll do it right underneath the move stars. So this is going to be function move meteors. So the first thing that we need to do is check if we have less than the maximum amount of meteors. So we have the meteors array, so we can use that to know how many we have. So if the number of meteors is less than, actually I'm going to use a while loop, and I'll show you why in a second. So while it's going to be meteors dot length is less than max number of meteors, we need to add meteors to get it to that point. So that's why I put it inside of the while loop, because we might need to add more than one. So the first thing that we need to do is declare a new web image for that meteor. So it's going to be variable new meteor equals new web image. Now, just to keep the code consistent with having all of the web images together in the top so that we can just update them right away, I need to access this web image for the meteor. The way I'm going to do this is write a quick helper function. So at the bottom with the other helper functions, I'm going to write a function called getImageURL. So this will return the URL that's stored in a web image object. So inside of here, I'm just going to put a return statement. This is going to return, and also we need to pass in a web image. So I'm going to have a parameter called web image. Make sure that web image has a lowercase w in this case, because we don't want to get confused with the actual object. This is just a reference. So inside here, we're going to return web image dot source, or web image dot image dot source, so src. So I was able to find that you can access the URL by using the image dot source, because you can actually look at the documentation, and if you find where the web image is at, you can see the code So right here you have the constructor for the class, and you pass in right here the URL, so it's the parameter is called file name, and then you can see it assigns this .image.source to that file name. So this just meaning it's a member of the class, and so you can access the URL. So in this case right here, it's the file name that you pass in. You can access that by taking the reference to that web image and then using the .image.source. One thing I'd like to note is it's always better to use getter and setter methods if possible to access the variables instead of setting them directly. Say you wanted to get the x position of an object, it's better to use the getX method than to try to just access the variable directly. And here's an example of why that's the case. And I'm going to use the set rotation function right here as an example. So right here you can see you can give it degrees or radians. And then like I showed you earlier, if you use degrees, it actually converts it to radians since that's what it uses internally. But otherwise, if you give it radians, it'll directly assign its rotation to the degrees variable, which it's a little odd naming since it could be radians, but most of the time I think people use degrees, so they chose that name. But anyways, let's say that CodeHS decided to change this function or this class. Let's say that they decided instead of using radians internally, we're going to switch to degrees. Now, let's say that you wrote code that directly accesses their rotation variable and sets your rotation that way. So what you were doing before would be in radians, since it works in radians internally right here. The problem is when they change it to degrees, your code breaks down because you treated the variable as if it were holding radians, but they just changed it to use degrees. So the advantage to using these getter and setter methods that they provide you is if you're using this to set the rotation and you were giving it radians, what they would do is modify their function. If they change this to using degrees internally, instead of right here converting the degrees to radians, they would pass in degrees directly and then convert the radians to degrees. So you can see using the getter and setter methods instead of directly accessing the variables is a much better practice. But there is no method for getting the URL of a web image. So in this case, I just have to code it that way. Now back in the code editor, we can continue writing the move meteors function. So now that we have this get image URL function, we can write that right here. So get image URL, and then inside of here we want to get the reference to that object that we declared. So object map.meteor, that will get the URL that we put in right there. So object map.getMeteor. There. All right, the next thing that we need to do is assign the meteor a new position on the screen. So I'm going to do that by calling new meteor, then .set position. And then right here, we need to determine where we can put it. So actually, we're going to use another while loop. And the reason is we need to set it to a position that's not too close to the spaceship. Like I said earlier, we don't want it to immediately appear on the screen. So what I'm going to do is choose a random place within the map, and then it will keep assigning it a new place until that position isn't too close to the spaceship. So inside of here, I'm going to move this set position outside of the while loop, and then I'm going to write a new variable, and this is going to be called variable x position, and then that we're going to set to a random number, and then variable y position. So next we need to use the randomizer to get a random place, so we can access that by using uppercase randomizer dot next and then I'm going to do integer, next int. Next, we need to give it a range that's within the world, so I'm going to use the constants world top left x, so the upper left corner of the screen, and then world bottom right y, or bottom right x, not y. And then same for the y position except for the constants for y. Next, we need to check that these x and y positions aren't too close to the ship, and then keep changing the values until that isn't too close if they are too close. So I'm going to use the Getdistance function that we wrote earlier in the series. So Getdistance, it has to be less than the width of the screen in order to generate a new set of numbers. So inside of the Getdistance, I'm going to write get width divided by 2, and then get height divided by 2. So this will be the position of the spaceship, so in the center of the screen, and it's going to be the distance from that to the new x position, so x position and the y position. So I'll get the distance from where the new meteor could be to the spaceship. If that distance is less than the width of the screen, since we know it's going to be wider than it is taller, so that will also ensure that it's not too close on the top or bottom. But if it is, we need to then assign it new values again. So inside of here, I'll just put this code right here where we choose new random values. Next, now that we've got values that work, we can set the position of the meteor to x position and y position. Oh, I made a mistake. I said get meteor right here. I'm not sure why I did that, but it needs to just be lowercase meteor, not get meteor. We don't have a function for getting meteor inside of our object map. The next thing that we need to do is add the new meteor to the screen. So I'll do it right here. So add new meteor. And then the next thing that you want to do is add, or actually it's going to be meteors.push. And that inside of here, we're going to push the new meteor to that array. So new meteor, push the new meteor there. And that's important because if you don't, you won't be able to access later, but this will also run infinitely. And I made that mistake a minute ago, and I found that was the issue. All right, the next thing that we need to do is move the meteors around on the screen. What I'm going to do just to start out with is move them at the same rate as the world, so they're just going to be fixed in one place, so to speak, but they'll move around to make the spaceship look like it's moving, but move around at the same depth as the spaceship. And so what I'm going to do is so add a for loop, so this will be for variable I equals 0, I is less than meteors dot length, and then I++. So we're going to loop through and access all of the meteors within that array. So I'm going to make a new variable just to hold the current meteor that we're working with. So variable current meteor is going to be equal to meteors, the meteor reference at the I position at that array. So current meteor dot move. So we're going to move it. We're going to use that move function. And up here, I'm also going to declare a couple of variables. So move x and then move y. We're going to move it the same way as we did the other things. So for example, the stars right here. So current scroll x minus last scroll x. Move meteors. It's going to look similar to that. So the same for y. So scroll y minus last scroll y. And then we can use, typo there, we can use the move x right here and then the move y as well. And let's run that and see how it looks. So if I fly around with the spaceship, there you go. You can see it's added some meteors to the screen at random positions. You'll also notice since it can't put them too close to the spaceship, there won't be any when you come into the game. So that's a good thing, because it just would be so unfair to the players if you join the game and then a meteor just crashed into you immediately because it was put on top of you. And like the player wouldn't be very happy about that. So it's good that we have that code there. The next thing that we need to do is move them around on the screen. And in order to make it kind of random, we want to give each meteor a random rotation, and then it'll move in that direction. So when we add the new meteor, we can also call the set position function. So new meteor dot set, or set rotation function. This is going to be, I'm going to use a float for more variation. So it'll be randomizer dot next float. And remember, by default, the set rotation function takes in degrees if you don't specify what unit. So I'm just going to leave it that, since it's easier to read. It's going to be between 0 and 360. So a new float, meaning like decimal number between 0 and 360. The next thing that we need to do is move in that direction. And this is where we move things in a rotated direction. So similar, how do we move the ship, using a little bit of trigonometry. But we did already write some functions to help with that, so we can use those again. The other thing I'm going to add is a get rotation function. So kind of like how we have the get image URL, I'm going to add a get rotation, and that will take in a shape, and it's going to return shape.rotation. So inside of the Code.js documentation, you can see that the variable for rotation of a thing is just called rotation. So that's what we're accessing here. And like I said earlier, if they had a get rotation function, which would be handy, but they don't, definitely use that instead. But since they don't have one, I'm just accessing it in that way. Also, thing is just like the parent object of all of the other ones. So like a circle is a thing, a web image is a thing. You can see in the code right here, uses thing. So back over to Meteor Galaxy, we got the get rotation function. So we're going to use that. So inside of the function that we were working on earlier, move meteors, we need to move the meteor in a rotated direction. So we still want to have it move around on the screen to make the ship appear like it's moving. So move with the other things that are at the same layer. So we're going to keep the scroll x minus last scroll x. We're just going to add the other distance it's going to travel in the x and y axis to that, so that it'll keep both types of movement. So to do that, we're going to need to add to move x. So move x plus equals, and then we're going to use the function that we wrote earlier, the get move x and get move y. So those have the trig in them. So get move x, and then get move x takes in the angle. So that's going to be get rotation of the current meteor. Then for the distance, it's going to be meteor speed, so the constant that we defined earlier. And then for move y, we're going to add get move y, and then it'll look pretty similar. So get rotation of the current meteor, and then also travel at the meteor speed. Oh, I made a little mistake. I need to add, so this current meteor, I'm going to move to the top since we're referencing it right here. So we can't reference a variable that we haven't yet defined. So I was getting this error right here. Let's run that and see if we can spot any meteors moving. Oh, you can see right here, they're all moving in the direction they're rotated. So that looks pretty cool. They're moving around, they're kind of lively. You can also see that they're, when I move the spaceship, it doesn't ruin the effect because they still move around with the stars. It's just they have their own movement on top of that, which we're adding right here. So that's pretty neat. The last thing that we need to do is make the meteors disappear if they go outside of the world bounds. And so I can do this. I'm just going to wrap this in an if-else statement, and I'll show you why in a minute. So if, and then else, and then I'm gonna put the brackets like this, and tab that in. All right, so right here we're gonna check if the meteor is too far outside, otherwise we can move it. So if we're gonna say get distance, the distance is going to be from 0, 0, so the center of the world, to the meteor dot get x, or current meteor, and then dot get x to get the x position, and then current meteor dot get y. So we're going to get the position of that meteor and check its distance to the center of the world. And then from there, if that is greater than the world width, since we know that the width is wider than the height, so it'll also cover that. If that's greater, we're going to say current, or the meteors dot remove. So this is removing an element from an array. So I'm going to remove the current meteor so that that be at position I. And also I'm going to, after that, I'll call remove and then current meteor. So we're going to also remove that from the canvas. All right, now that we're removing the meteors, once they get too far off the screen, that means that we won't run out, because essentially they'll all be traveling in their own direction, and then they'll get farther and farther and farther away, but without this. But since we have this, it can then get rid of meteors, and then right here, since we have less than the max number of meteors, it'll add more to the screen at random spots there off the camera, since they're a certain distance from the ship. All right, now that we got that, let's run it. Little typo right here. Let's run it. And we can fly around, and probably doesn't look a ton different, but before you added that, if you played it a bunch, you might notice that the meteors gradually begin to disappear. So that's pretty neat. We got meteors, we got stars, we got the spaceship flying around. All right, that brings us to the end of this video. Thank you so much for watching. I don't have the meteors colliding just yet, but that'll be added later. One of the reasons is it makes it easier to test, since you don't have to worry about colliding with the meteors as you're firing the laser beams. And also, I didn't want to make this video too long, so I'm going to save that for a bit later. I hope you all enjoyed and that you have a great day. Goodbye.